When we purchased the Horsepower Monster Project Camaro off of eBay, we knew right away that we were going to want to build an interesting motor to replace the weak Reman 350 that was already in it. Incidentally, that was also about the same time that Callie's approached us with their Ultra XD rods, which are designed to make building a big inch stroker a lot easier. That put the wheels in motion for our next build. It's a 427 inch small block, and it's going to feature Callie's rods, a dart block, K1 crank, and comp valve train. Now, a 427 inch small block has been done before, but it almost always requires a ton of machine work and massaging on all the parts to get it to work. This time around, we're going to use all off-the-shelf parts, and besides a little bit of work up front to get everything balanced, it should practically fall right into place. Follow along and you'll see. You can do this build using a stock Chevy block, but we decided to go with Dart's SHP block because it's stronger and it'll make your life a lot easier. The SHP block can be ordered with a 4.125 inch cylinder bore, and that's the unit that we'll be using. It can already handle up to 3 3/4 inches of stroke. We'll still have to clear a little bit for our 4-inch crank, but not nearly as much as we would with a stock block. And since we're using so much stroke, Nathan Allman of KT Engine Development smooths the edges at the bottom of the bores after honing to make sure that we won't scrape a piston skirt. We're sticking with the standard 9-inch 25 thousandths Chevy deck height, which means the longest rod we can realistically use is 5 inches 850 thousandths. The piston is a high-strength CP bullet forged piece with a minimal compression height of 1 inch 125 thousandths. Still, the extra long 4-inch stroke of the K1 forged crankshaft means the counterweights will hit the piston skirts. Along with balancing, the first step for an extreme stroker build like this is clearancing the crankshaft's counterweights. Balancing a crank while clearancing the counterweights at the same time isn't a tricky process, but it is more time consuming. KT Engine Development in Concord, North Carolina is helping us with all the machine work and dyno testing. And the first step for Kevin Troutman is to set up the bob weights and see where we're at. Although K1 does offer balancing from the factory, we wanted our crank heavy so we could remove material where it needed for clearancing. We were able to begin by cutting all the counterweights on a lathe because the piston and rod combination is pretty light. Eventually, we reached a point where we couldn't cut the counterweights on the lathe anymore because it started cutting into the sides of the rod throws thanks to all that extra stroke. It's time to move on to the manual labor stage of the process. This time around, in addition to checking how far out we still are on the balance, Kevin Troutman also marks where the pin towers hit the counterweights and approximately how much must be cut to achieve at least 1/8 of an inch of clearance. Now using air tools, the counterweights are ground to create the necessary clearance. Obviously, this isn't done in a single pass. Instead, the process requires many trips back and forth to the balancer as we sneak up on the final balance. This takes time, but getting quality work done here is paramount. For example, KT Engine Development normally charges around $200 to balance the crankshaft. But for work like this, the final tally will be closer to $400. That's okay though, because we expect this to be the only major handwork required to build this engine. With the balancing work finally complete, the next step is to make sure the big end of the rods don't contact the block as they swing by on that extra long rod throw. The crank is laid in the Dart SHP block, and a rod and piston are mocked up so we can mark any places where the rod hits iron. By swinging the crank in both directions, we can see the full depth of how much needs to be cut. Thanks to the SHP block's ability to handle as much as 3 3/4 inches of stroke, it isn't necessary to remove much material. KT Engine's owner Ken Troutman has set up the block in a milling machine to begin the cutting process. You can do it all by hand with a grinder, but a milling machine makes the work much more precise and it goes by that much more quickly. And here you can see just how little was required to be cut away. Stroker motors put extra stress on the block. To help strengthen everything as much as possible, we swapped out the bolts securing the main caps for a main stud kit from ARP. One thing to be aware of is that the Dart SHP block requires its own cam bearings. Unlike a stock Chevrolet block, the cam bore is 2 inches all the way across. Now Dart will sell these bearings for you. They've got their own part number, which we'll give you in the build notes, and it's a pretty good set of cam bearings. They're coated for better wear resistance, and there's a groove cut in the back to allow oil to travel all the way around, so it can go through one of the 3 oiling holes cut in the cam bearing to allow you to make sure you get plenty of oil to your cam. Installing cam bearings is a straightforward process, but it does require a specialized tool to make sure they're driven into the block squarely and without damaging the bearings. If you don't have a cam bearing installation tool, an engine machine shop should be able to do it for you without too much cost. With the bearings installed, we can mock up the camshaft from comp cams, press in the upper main bearing shells, and drop into place the crankshaft once again. Comp has prepared a very impressive cam for this build, and we'll get into the details of that more later. For now, we just want to make sure the big end of the rods don't hit any cam lobes. For most builds using a 4-inch stroke and a small block with a standard cam location, making everything work requires grinding down the heads of the connecting rod's cap screw bolts. But that isn't necessary here because of the unique Callie's Ultra XD connecting rods we're using. Callie's cants the fastener off the vertical as you can see here, and that moves the bolt closest to the cam further away from danger by as much as 50 thousandths or even more. Combine that with the fact that Comp is capable of providing its excellent lobe designs in a reduced space circle cam grind, and there's more than enough clearance without having to resort to grinding on the connecting rods. That's a good thing because anytime you've got to grind on a connecting rod, it's going to weaken it. That's the last of the clearances to be checked, so we went ahead and cleaned the block one last time, gave it a coat of high temp paint, and installed the freeze plugs. You should note that the Dart SHP design utilizes 3 freeze plugs on each side of the block, plus 2 each on the front and rear. A stock Chevy block uses only 8, so if you order a standard freeze plug kit, be aware that you're going to wind up short by 2. And that brings us back to where we are now. We've got our crankshaft balanced and clearance for the rotating assembly. We've got our block notched to make room for the spinning rods. We've even installed the comp cam's camshaft and a couple of pistons and rods to make sure that they don't knock into each other when the engine spins. Next time around, we're going to have more fun. Things will actually start going together. We're going to fit bearings and start building the short block.